Okay, so esters. And I'm basically looking at page 46, but I'm going to write a few other things up here. What does that mean? Yeah. What's an alkyl group? So some people told me that basically isomeric means they're isomers. So they have the same molecular formula, but they have different structures. Okay, that's all right. Well, what's an alkyl group?
Is it like sodium?
The carbon.
I was going to say like carbon attached to more, like part of the chain,
Carbon attached to what?
like hydrogens or
Hydrogens. Yeah, so that's right. So carbons and hydrogens. So an example of another context would be an alkyl halide. Okay, is like his. That's an alkyl halide, isn't it? If you look on your formula sheets, so what we're saying is the carbon-hydrogen part is the alkyl group. So if we look then at a carboxylic acid, hopefully you're all happy that that is a carboxylic acid. What's its name? Propanoic. And what we're saying then that we can actually write an isomer of that and instead of having, so this part here says they have an alkyl group attached to the oxygen rather than a hydrogen. So if I had a hydrogen on here instead of this alkyl group, it would be a carboxylic acid, wouldn't it? But that's not the case. What's the name of this one? Now we haven't, you did a little bit of naming a while ago, but we haven't spoken specifically about naming esters. What's this one's name? Any idea?
Does it end in ATE?
It does end in 8.
Would it be ethanoic?
Which one?
Ethanoic?
Ethano.
Methyl ethanoic.
Methyl ethanoate. It's methyl ethanoate. This comes from methanol. And it's really to do with the way esters are produced. The way and we'll talk about this in a moment, but we produce esters by reacting an alcohol with a carboxylic acid. And this is where our methanol was. Okay, that's the methanol part. And so the first part is where the H would be for an alcohol, right? So that's what this part here is about. And then the last part here is named according to the carboxylic carboxylic acid. Okay, so if this was a hydrogen, then we would have ethanoic acid. So that's where we get the ethane part. Or you can think about it in terms of formation as well, that this part was formed from the carboxylic acid. Now, anyone want to tell me what sort of bonding is present? We're talking about intermolecular bonding here. In our ester, not in the carboxylic acid. What do we need for hydrogen bonding? A hydrogen bonded to an oxygen. Do we have that? No. No hydrogen bonding. What's the next thing that we'll look for then? Dipole. Do we think we might have that? Yeah. Why? Yeah, we've got these oxygens here that are going to be slightly negative, aren't they? Okay, so this sentence now, we've just decided that we've checked, we can't see any hydrogens bonded to our oxygens, so there can't be any hydrogen bonding. But we have got oxygens present, so yes, we have dipole-dipole bonding. What does that tell us about the boiling point of an ester if we compare it to its isomeric carboxylic acid? Who votes for lower? Yes, so they have a lower boiling point. Okay, we might just rub that off so that I can write a little bit higher on the board. At least I'll rub this bit off the top here. Now, the reactions to form esters is called esterification. So this is how we form esters, is by reacting alcohol with the carboxylic acid, but we need to do it in the presence of heated sulfuric acid. And it's done, if you want to have a decent yield, it's done as a reflux reaction. And you might see that kind of terminology in an exam, and we will do this experiment. But I'm leaving it until the end of next week so that we hopefully will have covered all of the content that we need to have for the exam by then. But we'll make some esters and you'll be able to see what that reflux reaction looks like. So now if I look at then at how am I going to write this out as an equation? So what am I representing here? Carboxylic acid. And this then is the alcohol. And we've got this arrow again, indicating what?
Equilibrium.
Yeah, it's an equilibrium arrow or reaction, which means that it doesn't go to completion. Okay, so we don't react these and end up with only ester and none of these remaining. We're just going to put our acid on the arrows. Okay, so this part here is represented as just the hydrogen ions on the arrows, because if I try and include sulfuric acid in my equation, it's just going to make it very difficult for me to balance. And what happens is, you don't need to necessarily know this part, as in which bonds are broken, but these are the bonds that are broken. What have I got in the red dashed line? Water. So that is that's my other product. When I react my carboxylic acid and the alcohol, I form the ester and water. And this is an important property of esters, that they are sweet smelling, because you might be given that as a clue in an exam question, that it might say something about a sweet smelling compound. That's going to give you, the clue that it's the ester that it's talking about. Okay, now another thing that we need to know about our esters. So this, if we're thinking about this as going in that direction, then we're doing this to produce the ester, aren't we? But we can easily reverse the reaction. And so what this is telling me, esters can undergo hydrolysis reactions. What do you think a hydrolysis reaction involves?
Water?
Yeah, so this is saying adding water, which is why this then can go back the other way. If I react an ester with water, I can form the carboxylic acid and alcohol from which it was originally derived. Okay, so we can reverse that reaction. We call this hydrolysis because we're adding water. And In this case though, okay, so if I'm starting with my ester and I'm adding water, still in the presence of acid, this one's one way, okay? This one is not the reversible one. Now, there's a naming hint in the booklet. It says, if you drink alcohol, then you'll get an acid tummy. To try and remind you to name the alcohol part first before the acid. I don't know if that works for you, but the alcohol part, the one that's attached to the single oxygen, is the one that's named first. If you look on your formula sheets, you can see you've got an example there anyway. We've got methyl propanoate, and you can see that the methyl part is the one that's attached to with a single bond to the oxygen. Yep, and then the propanoate comes from the propanoic acid end of the molecule. Does that make sense? So you can always refer back to the formula sheet if you get yourself confused. This will tell you which way around to name it.
Why do I have my acid present again?
Because it's just not going to happen without it. It's
Don't I need that to go the other way?
yeah, you need it for both ways. It needs to be done it's just an acidified environment is required for the reaction to proceed. Yeah, that's basically it. All right, so we've talked about the physical properties and we've talked about them having sweet smells. So on page 47, we can see that apparently some of them smell like banana, apple, orange and pineapple. Whenever we've done the ester crack, I've never ever smelt anything anywhere near that good. More like locker room or smelly socks or something like that is the best that we've been able to do. And there are a couple of examples of reactions down there on the bottom of page 48. Now, do we think we're going to be able to oxidise our ester? No. No, we really haven't got any carbons there that are available, are there? So, we're going to be identifying it with its sweet smell at the moment, and then we'll look at other ways we can identify it later on. But I'll get you to work on those questions now.